Hi, and welcome to Lesson 8 in our discussion of the nucleus. As we said in our discussion of nuclear fission, here at the end we're going to be talking about some quirky things that nuclei do. And so I've decided to go with this giant yellow ball of gas as a demonstration of our next discussion, which is nuclear fusion. All of the heat and light that is produced by the sun is the result of nuclear fusion reactions. So let's go in and take a look at how those work. Nuclear fusion refers to the production of larger nuclei by combining smaller nuclei. This is one of the major fusion reactions that happens in our sun. You can see that hydrogen isotopes are being smashed together to produce helium isotopes. This is the process that powers the sun and all other stars in the universe. Not only that, but it's also the place where all of your atoms came from. So it turns out that every atom heavier than hydrogen is actually made through fusion reactions inside of stars. During a star's life, hydrogen gets fused together into every atom from number 2, helium, up through number 26, which is iron. And then, of course, the star dies. And when a star dies, it undergoes a fantastic explosion called a supernova, which is one of the most chaotic and energetic events that we are aware of in the universe. When that star dies, the energy that comes from that supernova actually drives the fusion of elements heavier than iron, all the way up to element number 92, which is uranium. And then these clouds of elements can condense into other stars and undergo additional fusion reactions, or in the case of our solar system, serve as the basis for what became the planets, including the one that we're on, giving rise to all of the life on Earth and all of the atoms in that life. Every atom in your body was made this way, and I'll suggest that that is one of the coolest things that science has told us about our place in the universe. The fact that all of the atoms in our bodies are the products of fusion reactions and supernova explosions in the stars of the universe is amazing. At least it's amazing to me. I hope it's amazing to you too. We would very much like to be able to carry out fusion reactions on Earth, but we've never been able to carry out a sustained fusion reaction. It's really very difficult because of the fact that atoms don't want to be squeezed together. You need tremendous conditions of light and heat in order to carry out sustained fusion reactions. And the only places in the universe that we're aware of where this happens is in stars. We really cannot simulate star-like conditions on this planet in any sort of sustained capacity. But this is the design for a theoretical fusion reactor that is currently being built and is hoped to be operational at some time in the next decade. At the same time, there's a lot of things that could go wrong between now and then. So don't be surprised if the next decade comes and goes and we still haven't yet figured out how to produce a sustained fusion reaction on the planet. But notice in that last slide that I said sustained. We have developed fusion-based weapons. These are what are called hydrogen bombs. The way a hydrogen bomb works is that it uses a fission explosion to trigger the fusion of hydrogen into other isotopes. So what you see down here is the series of events that happens over the course of a fusion bomb's detonation. You actually use a fission reaction, and that fission reaction then drives the fusion of a mass of hydrogen. This entire series of graphics is a time series showing the events in a fusion bomb that happen in less than 1 second after detonation. Fusion bombs are actually the most destructive weapons that have ever been produced. They produce energies equal to millions of tons of TNT. So this is a picture from the Bravo test, which was a test that the United States government did in the middle part of the 20th century. And the yield of this weapon was 15 megatons of TNT. So remember that fission-based weapons have yields of kilotons of TNT, or 1,000 tons of TNT. Fusion-based bombs produce energies on the scale of megatons of TNT, or millions of tons of TNT. These weapons are the most destructive weapons that have ever been created by humankind, and fortunately they've never been used in a conflict. This chart, which is on page 18 of your packets, compares fission and fusion, and you know that I like charts like this, so I'm encouraging you to take a moment and go and look at this chart to make sure that you can recognize fission reactions, fusion reactions, understand what is similar about them, and understand how they differ from each other. Before we wrap up, let's talk a little bit about the world that we live in. So the United States created and used the first nuclear weapons to end World War II. And since then, many other nations have become members of the nuclear club. So on this map of the world, every nation in blue is a nation that has legally developed and tested nuclear weapons. The countries in red are countries that have developed and tested nuclear weapons illegally or outside of the sanction of the United Nations and the International Atomic Energy Agency. And then the nations in green, which are South Africa down at the bottom, and a couple of former Soviet republics which lost their membership in the USSR after the Soviet Union collapsed, used to have nuclear weapons, or at least access to them, in the case of the former USSR republics, but have actually given it up. South Africa is actually the only nation on Earth that has peacefully stopped producing and using nuclear weapons after having developed it. And then there's a tiny yellow spot on this map, which is Israel. Israel has never confirmed that it has nuclear weapons, but it's understood that it does, and so it has a different color on this map. These are all members of what we call the nuclear club. The United States, of course, remains the only nation that has actually used nuclear weapons to end a global conflict at the end of World War II. Thanks so much for watching this discussion of nuclear fusion. Make sure that you can do the following things here at the end. Make sure that you can explain what happens during fusion reactions. Make sure that you can describe how fusion has produced every atom in your body. Make sure that you can explain why fusion is both very desirable and very difficult to achieve. And finally, make sure that you can compare and contrast fusion reactions with fission reactions. If you can do all of those things, you're doing great. If not, that's okay too. Take a moment and write down any questions that you have. You can always leave those questions in the comments below the video, or you can always get in touch with me through the information in the info field. Thanks again for watching. I really appreciate it. Have a great day.